Right, this is video 2.1 for Algebra 2. We are going to be talking about solving linear equations and linear inequalities. Just a few vocabulary words before we get started. An equation is going to be a mathematical statement that two expressions are equivalent, like 2x equals 10 would be an equation. So what's important about that is that you have the equal sign in there. That's what makes it an equation. Solution set is going to be any value or values that make that equation true. So if you have 2x equals 10 as your equation, then x is going to be equal to 5. 5 will be the value that is in the solution set. And in this case, there would only be one value in the solution set. So a linear equation is always going to be in the form of ax equals b, like 2x equals 10, where you have two different numbers. A is not a 0, because if it were a 0, then the whole thing would be, you would have to divide by a 0, which is not something that you're allowed to do. An identity is going to be an equation that ends up being x equals x, which is going to be true for all values. So if you solved it and you got x equals x, then x can be anything because it will always be true, so that's an identity. The other way you can do it is if you come up with an equation that has no solution, which would be a contradiction. That usually ends up, if you worked it all out, your x's will completely disappear and you might end up with 2 equals 10, in which case 2 will never equal 10, and so then that is a contradiction. And an inequality is going to be a statement that compares two expressions similar to an equation, but instead of using an equal sign, you use greater than, less than or equal to, greater than or equal to, or not equal to. That would be an inequality. So let's get started. A few properties of equality. These you should already know. You can add, subtract, multiply, and divide to both sides of the equation as long as you're doing the same number, and the equation will still be true. So if you add something to one side, you add it to the other side to make the equation still true. If you're subtracting, subtract the same thing from the other side. Multiplying and dividing, same thing. So let's solve an equation using the distributive property. So the first thing we're going to do here is, there's actually two ways you could do this. Most of the time what we would do is we would distribute our 5 to everything inside. So we would say 5y minus 35 is equal to 25. We add 35 to both sides, giving us 5y is equal to 60. Then we divide by our 5, giving us y is equal to 12. So that would be the distributing before you solve. The other way you could do it is you could go ahead and divide everything by 5. We can divide by 5 here and divide by 5 there, giving us y minus 7 is equal to 5. Then we add our 7, giving us y is equal to 12. You come up with the same answer. Most of the time I think this way first, but you could actually do it either way. So if we have variables on both sides, all we're going to do is use our properties of equality in order to move the variables to one side or the other side of the equation. The best thing to do is to go ahead and combine like terms on the same side before you move it across the equal sign. So I'm going to combine like terms here. I'll have my 6y plus 28 is equal to 9y minus 20. Now, some people like to only gather their variables on the left side. I prefer to gather my variables so that they will be a positive. So I'm going to move my 6y over. I'm going to say minus 6y and minus 6y. Since I'm moving my y's to the right side of the equal sign, I'm going to move my numbers to the left side. So that is a minus 20. So I'm going to add 20 and add 20. It's going to give me 48 is equal to 3y. And when I divide by 3, I'll have 16 is equal to y. So identities and contradictions, this is what they're going to look like when you're solving them, so that you know when you're going through your work whether or not you've come up with an identity or a contradiction. So let's do this one first. I'm going to combine like terms, so my 3x and my 4x, that would be a 7x. Right here, we can already see that we have a 7x plus 5 on both sides. So I'm going to show you what it looks like when you bring it down. So I'm going to move my 7x here. I'm going to move it to the other side. And I'm going to move this 5 to this side. And I'm going to end up with 0 equals 0. So that would be an identity. Anytime you end up where you either have x equals x, or a number equals a number, or a 0 equals a 0, if they're both on the same side, if they're both identical, then it will be an identity. So you can put any x you want to in that equation, and you're going to get a true statement. Let's try this one now. I'm going to go ahead and distribute my 8y across. So I'll have 8y plus 56. Combine these two, I'll have an 8y minus 8. So I'm going to move my 8y over, subtract 8y, subtract 56. So on this side, I end up with a 0, and on this side, I end up with negative 64. So is 0 equal to negative 64? It is not. So there is no way this is going to ever be possible, so we would call this a contradiction. So if you lose your variable, when you get all done solving out, if the variable goes away, you either have an identity or a contradiction. If it is a true statement, like 0 equals 0, 1 equals 1, then it will be an identity. And if it is a false statement, like 0 equals negative 64, then it is a contradiction. Now, an inequality is going to basically work the same way. The biggest thing you've got to be careful for, this is the thing I see most people make a mistake on, is when you are multiplying or dividing by a negative number. So multiplying or dividing by a negative number, you have to flip this sign. That's the only thing you really have to watch out for. Adding and subtracting, multiplying and dividing by a positive number doesn't change anything. It's if it's a negative number that you're multiplying or dividing by, that's going to flip it. So let's solve this one. Like I said, I like to have mine be positive when I do this. So instead of moving my 12, I'm going to move my 9. So I'm going to subtract 9x. Add 11. I added an extra line there. Add 11. So that will give me 15 is less than 3x. When I divide by my 3, that will give me 5 is less than x. So let's say I moved it to the other side instead. So let's say I did 9x plus 4 is less than 12x minus 11. And I moved my 12x over because I wanted to gather my x's on the left side. And I moved my 4 over there. Then over here I would have negative 3x is less than negative 15. So that when I divide by negative 3, because I have a negative, I'm going to flip that. I would have x is greater than 5. These say the same thing. They're just in opposite orders. What's important is that this is 5 is less than x and x is greater than 5, which is the same statement. So just make sure that if you're dividing by a negative number that you flip that inequality sign. Now to graph this, it's going to be on a number line. Okay, so the only thing I'm expecting out of your graph, take the number that you bring it down to. You're going to be an open circle if it is just less than or equal. Less than or greater than is going to be open. If it has a line underneath it because it's less than or equal to or greater than or equal to, that will be a closed circle. So my 5 is less than x, so it's going to be an open circle. Now the direction of the arrow is super duper important. Okay, so I want everything where 5 is less than x. So anything, the x has to be bigger than 5. So it's going to be this direction. Now, if you write your equations, your answers, so that you have your x on the left, and then your inequality, and then your number, if you look at your inequality, it kind of makes the end of an arrow. It makes the end of this arrow. So we have open circle, arrow. Do you see how that is a greater than sign? But it has to be in this order. It doesn't work if your x is on the right. It only works if your x is on the left. So just double check and make sure that your arrows go in the right direction. We want x's that are greater than 5, so that's going to be anything bigger than 5, not including 5. That's it for today. Go ahead and have a great evening, and I will see you when we get to class.